In the previous video, we began looking at measures of central location, and we looked at three of these. Right, they were all a variation on the mean, but we had the arithmetic mean, which is our just standard average. We had our weighted mean, where the individual observations don't have to have the same weight or same importance. We can vary that as we wish. And finally, we looked at the trimmed mean, which was where we took off an equal amount of the highest and lowest values from our data and calculated an arithmetic mean. Right. So those are pretty important measures of location, but there are two others that we need to talk about. So we're going to briefly go over those, and then we'll talk about, talk a bit more about just some other things involving this idea of measures of central location. All right, but without further ado, let's go ahead and put those down. So I'm just going to write down the definition of these, and these are things that we're probably all at least somewhat familiar with. Most of the time we're talking about means, we're also talking about the median and the mode, and those are the other two measures of central location. All right, so the median, just to refresh our memory, right, this is the data value in the middle of an ordered array. All right, so an ordered array just means your data is in an order. So usually from smallest to largest, although for the median it doesn't really matter. But it does need to be in order. All right, then our mode is the most frequently occurring values. All right, so whatever value is most frequent, right? So shows up the most in our data set. That is going to be our mode. All right, just so we have an example of this, I'm going to go ahead and clear this board, so if you don't have it down, you might want to pause it and go ahead and write these down. But let's say that we're going to use the same data we've been using, all right? So from the last video where we were doing our means. All right, so we're going to have 19, 23, 23, 26, 29, 31, 31, 35, and 10, 17. All right, so that is our data set. All right, so if we're looking for our median, right, we want to find the value in the middle of the data set. All right, so we can look at this and we can see that we have 9 values. And so we can kind of just split that. Well, we could do this multiple ways. We could just go, all right, so that's 1 from the ends, 2 from the end, 3, 4, all right, and so there's 4, so that leaves 29 as being in the middle, right? That is a perfectly good way to do this. Oop, that's kind of there we go. All right, in fact, when you've got a small data set like this, might be the easiest way. There are some other ways. Actually, we're going to just leave those, and we'll talk about those in a different video. All right, but that's it, right? You want to find the value in the middle. If your sample size is even, right? So here we had an odd number of samples, all right? Our sample size was odd at 9. If it's even, then the median is the average of the two middle values, right? Because if you have an even sample size, you're not going to have one value that's directly in the middle with an even number of observations on each side of it, like we did here. So you're going to have two numbers that fall in the middle, right? And so you just take the average of those, and that's how we get our median. All right, then our mode is just the most frequently observed value. All right, and so we just scan this and we see that we've got 23 has 2, and 31 also has 2. All right, so all the rest of our numbers, it's just one occurrence of them. 19, there's only one 19, 26, so on and so forth. All right, so 23 and 31 are both the most frequently occurring. Right, so that means our mode is 23 and 31. All right, so an important thing to note is that we can have more than one mean, or excuse me, that we can have more than one mode. If there are a number of values that occur just as frequently and they are the most frequently observed, then anything that falls into that category is going to be the mode. Right? That's kind of a weird way of saying that, but what we're seeing here, right, is just what's happening with this example. Right, we've got two values that occur the most, right? They're tied for most frequent, and so both of those are going to be our mode. All right. So that is it for the median and the mode. So we'll be moving on in a second. So what we're going to be talking about next is just kind of discussing the reason why we might want so many different measures of central location. Right? I'll go ahead and tell you that the arithmetic mean is going to be the one that we're going to use and be working with the most. So why do we want these other ones? All right, well, there are kind of two possible answers to this. All right, one is that not all of our data is kind of suitable for the different measures. All right, so let's take a look at our different measures. All right, and we're going to look at them in the context of our levels of measurement. All right, so if we don't remember that, so noir, those are levels of measurement, nominal, ordinal, interval, and ratio. Right, and some of these are more appropriate than others for our different measures. All right, so if we're looking at our means, all right, so this would apply to our arithmetic mean, our weighted mean, and our trimmed mean. All right, we cannot, all right, if we've got nominal data, right, so data that just are labels, descriptions, right, they can just categorize stuff, right? Well, we cannot, right, calculate a mean for nominal data, right? Mostly because a lot of times nominal data is represented as just kind of words, and we can't do math with words, right? We can't do math with that categorical data. Nominal data is categorical. Then we move on to ordinal. Right, so once again, ordinal data is categorical data. We cannot calculate a mean using categorical data. Right, then we move on to interval. Right, interval is is quantitative, right? We've got numbers to it, numbers with it. Let's see, that's not what I wanted to do. And we can calculate means for interval data, right? So one of the big examples of interval scale data was temperature, and people calculate average temperatures all the time, right? So we can definitely do that. And then if we can do it with interval, we can also do it with ratio, right? Because ratio is just higher quality data. All right, so if we've got data that is quantitative, all right, so interval or ratio scale, then using a mean, whichever one is we want to use, right? We can use that to calculate that measure of central location. All right, so why might we want to use the median? Well, probably it becomes pretty clear. All right, there's things that we can't do with the mean. Maybe we can do those with the median. So looking at these, I'm going to go through these a little bit faster. All right, median. The thing that you have to be able to do to find the median is to order your data. Well, with nominal data, you can't put that in order. All right, and so we can't find the median for nominal data. However, once we get to ordinal data and beyond, we can put all of that data in a logical order. And so it is all, so we can find the median for ordinal, interval, or ratio scale data. Right. Last but not least is the mode. This is the simplest and also the most kind of widely available. Right. You can apply this to just about to really anything. Right. Any kind of data. All right. We've got our 4 levels of measurement here, and it's going to work for any one of those. All right. So if you've got nominal data, all right, and you want a measure of central location, right, the mode is going to be really your only bet. If you've got ordinal data, you probably want to go with the median. All right, although you could use the mode, but in that situation, the median's probably a little bit more informative. Or you just get both. It doesn't really matter. Right, and then once you get into quantitative data, right, it might be more. It might make more sense to use one of those means. All right, so rather whether it is the arithmetic mean or the weighted mean or what have you. Right, but again, not all of those levels of measurement or data measured using the different levels of measurement they're not all created equal. Right, there's some things that we can do with some types of data that we can't do with others. All right, based on these measures. All right, so we're going to need different measures to look into that. All right, so that's one reason. Right, another reason is resistance. All right, so a resistant measure is not overly affected by outliers. All right, so we're not going to worry too much about what an outlier is right now. At the end of this chapter, we'll talk a little bit more about these. But for now, really all we need to know is that they are values that are relatively large or relatively small compared to the rest of the data. Right? So if a measure is, and usually they're seen as, in some cases, depending on what exactly you're going to be doing, if you detect any outliers, you might remove those from your sample because you might say that they are they're not representative of the population as a whole. There are going to be just those giant observations that are either way bigger than the rest of your data or way smaller just by random chance. But that is the idea that they don't represent the rest of the data well. All right, so some people will cut those out. Some people will address that in a different way. But if we do have these outliers, these values that don't represent the rest of the data, and our measure is not resistant, that means that we could get a measure that is not representative. All right, so to make this a little bit less confusing, I will, actually, let's just put this down. All right, so using that same data that we've been using, so let's see, I don't know if I really need to write this down, but I will. So 23, 26, 29, 31, 5. All right. So we're not going to do all of the work again, but we are going to just run through these. So we've used this for a reason. Well, first, looking at this, hopefully we can see that we do have a potential outlier. It's almost definitely an outlier, right? Most of our data ranges from 19 to 35, and then we have 1017. So that's probably going to change things a little bit, right? So we do have an outlier, so what we're essentially doing is checking for resistance. All right, so if we look at our arithmetic mean, if you go back into your notes or back into that video, we're going to see that we had an arithmetic mean of 137.111. Oh, actually, I meant to do that in a different color. All right, also, I'm going to just use the symbol for the arithmetic mean instead of writing it all out. So the arithmetic mean, 137, and we'll just say 0.1. We'll just go to one decimal place for this. All right, we did not do a weighted mean for this because this isn't really the type of data that we would use it for. We did do a 20% trimmed mean though. All right, and we found our 20% trimmed mean to give us a 28. Let's see, what else do we got? These bright ones. I'm running out of good options. That's okay. All right, and then the last ones we did, and we have the median giving us a 29, and the mode, let's see how this red shows up. Oh, that's not bad. All right, and then a mode of 23 and 31. So just going back through those, we're going to just place those along our data. All right, so with our arithmetic mean, we've got that 137.1. All right, that is where that yellow line is. That is where our arithmetic mean falls, right? Kind of a little wonky, right? Because most of the data falls to the right of that line, right? And if we're wanting the central location, we'd probably prefer it to be somewhere more towards the middle, right? Then going for our 20% trimmed mean, we see it's somewhere in here, all right? A little closer to the actual middle, so that's pretty good. Then our median is 29, and it is in the exact middle, which is not necessarily, you know, you don't necessarily have to be in the exact middle, but you probably don't want to be out here where our yellow line is, right? That's pretty far. And then for our mode, we are at 23 and 31. All right, so the main purpose of this, kind of what we're trying to show, is that the arithmetic mean is not resistant. All right, so it is the one that is clearly most affected by outliers. That 1017, that pulled our average up quite a bit, right? That 137, that takes it pretty far away from the rest of our data. and would indicate, hey, maybe this isn't really representative, right? So most of our data is between 19 and 35. The vast majority of it is. So if our mean is 137.1, that could cause some problems depending on what we're trying to do with it, right? That is kind of the point of the 20% trimmed mean. Is what we're doing there. We're cutting off those values, an equal proportion of the highest and lowest values, right? The place you're going to find outliers are in the highest and lowest values, all right? So by cutting out the outliers or any potential outliers, right, the 20% trimmed mean is more resistant. The median's just whatever's in the middle, so outliers are not going to affect that. And then the mode is also resistant because outliers are, by definition, not going to be the most frequently observed value, right? If they are, then they're probably not outliers, right? And so when we're using the mode and looking for that most frequently observed value, that's not going to be, those are going to be the same whether we have an outlier or not. All right, so to kind of boil all of this down, the reason that we have all of these different measures of central location is because, one, the type of data, the level of measurement for the data we're using, right, it might not be appropriate for some of them, right? If you have ordinal data, you're not going to find the mean or the 20% trimmed mean, largely just because you can't, right? Unless you kind of arbitrarily assign numerical values to answers like some people do with those Likert scales that we mentioned much earlier in the semester. Right, so unless you do something like that, which is wrong and should not be done, you literally can't calculate a mean with that ordinal data. Right, because most of the time it doesn't have numbers naturally attached to it, right, or just attached to it at all. It definitely doesn't have numbers naturally attached to it. Right, so that's one reason. The next reason is resistance. Right, if we are unsure about the existence of outliers, right, we're worried that it's going to kind of mess up our results, we might not want to include those. All right, so for example, with our resistance, the average or the mean is used very frequently. One place that you'll find it not used as much is when people are talking about wages or salaries. Most of the time, people don't talk about average wage or average salary. Most of the time, it's talking about median wage, right, or median salary, right? So why is this? And if we think about it, right, it might make sense, right? If you're gathering a sample, you're looking at salaries. We'll just stick with salaries. If you get one or two, even just millionaires, probably in your sample, right? And especially if you somehow got a billionaire in your sample, that could really skew your data, right? So I think the last time I heard median income, I think this was just for an individual somewhere around $35,000. Right, so if you if you've got a sample, let's say you got 20 people in the sample, which is unrealistic, you're probably going to have more, but just for argument's sake, you've got 19 people in that sample that are somewhere between say $14,000 and $70,000, right, their salary, right, with and then you get one millionaire in there. That's really going to change that average salary, right? It's going to get us a lot closer to this yellow line up here than maybe we want to be, right? It's not going to represent what you're actually, it's not going to tell you what you're wanting it to actually tell you at that point, because if you're trying to get an idea of what people in the middle are making, if you have data that has those outliers, right, then you can end up with some misleading results, right? And so that's why we might want to use that median instead of an average. It's also why you're going to see that median used for wages, right, or salaries. All right, but that is it for measures of measures of central location. What we're going to be looking at in the next video are measures of dispersion. All right, but we'll talk about that in the next video. I will see you then.